flexible metal conduit, often referred to as FMC, can indeed serve as an expansion joint in certain electrical installations. This application leverages the inherent flexibility of the conduit to accommodate movement between two fixed points. The use of FMC as an expansion joint is particularly relevant in scenarios where thermal expansion and contraction, or structural movement, are anticipated. This is frequently encountered in buildings, bridges, or other structures subject to temperature variations or settling. The NEC, the National Electrical Code, provides guidelines for the proper installation and use of electrical conduits, including flexible metal conduit. When utilizing FMC as an expansion joint, adherence to the NEC is paramount to ensure a safe and code-compliant installation. Several factors must be considered to determine the suitability of FMC as an expansion joint in a specific application. Firstly, the anticipated amount of movement between the two fixed points must be evaluated. The flexible metal conduit must be of sufficient length and flexibility to accommodate this movement without exceeding its bending radius or causing undue stress on the connectors. Secondly, the environment in which the FMC is installed must be taken into account. If the conduit is exposed to corrosive substances or extreme temperatures, the appropriate type of FMC resistant to these conditions must be selected. Thirdly, the mechanical protection afforded by the FMC must be considered. If the conduit is subject to physical damage, additional protection, such as a protective sleeve or enclosure, may be necessary. The installation of FMC as an expansion joint typically involves securing the conduit to each fixed point using appropriate connectors. These connectors must be listed for use with FMC and provide a secure and reliable connection. It is crucial to ensure that the conduit is installed in a manner that allows for free movement without binding or chafing. This may involve providing adequate slack in the conduit run or using specialized expansion fittings designed for flexible conduits. While flexible metal conduit offers a convenient and cost-effective solution for accommodating movement, it is essential to recognize its limitations. FMC is not suitable for all expansion joint applications. In situations involving large amounts of movement or exposure to severe environmental conditions, other types of expansion joints, such as expansion couplings or bellows, may be more appropriate. Furthermore, it is important to note that the use of FMC as an expansion joint may be subject to specific requirements or restrictions imposed by local building codes or regulations. It is always advisable to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. In summary, flexible metal conduit can be used as an expansion joint provided that the anticipated movement is within the conduit's capabilities, the environment is suitable, and the installation complies with all applicable codes and regulations. Proper selection of materials, careful installation techniques, and a thorough understanding of the limitations of FMC are essential for a safe and effective expansion joint solution. Let's delve deeper into the technical aspects of using flexible metal conduit as an expansion joint. Consider the NEC guidelines. The National Electrical Code provides specific requirements for the installation of flexible metal conduit. While it doesn't explicitly dedicate a section solely to FMC used as expansion joints, the general requirements for conduit installations apply. This includes Article 348. It covers FMC in Article 350. It addresses liquid-type flexible metal conduit, LFMC. The applicable sections outline acceptable uses, installation methods, and support requirements. The NEC mandates that FMC be securely fastened in place. This requirement is also applicable when FMC serves as an expansion joint. The supports must be designed to allow for movement of the conduit without causing stress or damage. The code also specifies the maximum spacing between supports, which may need to be reduced when FMC is used as an expansion joint to provide additional support and prevent sagging. Another key consideration is grounding. The NEC requires that all metal conduits be properly grounded to provide a low impedance path for fault current. When FMC is used as an expansion joint, it is crucial to ensure that the grounding path is maintained across the joint. This can be accomplished by using grounding bushings or other approved grounding methods. The selection of the appropriate type of FMC is also critical. FMC is available in various materials and constructions, each with its own set of characteristics and limitations. For expansion joint applications, it is generally recommended to use a flexible metal conduit that is specifically designed for this purpose. These conduits are typically made of corrosion-resistant materials and have a flexible construction that allows for a greater range of movement. Liquid-type flexible metal conduit (LFMC) is often used in expansion joint applications where moisture or other contaminants are present. LFMC has a liquid-tight jacket that protects the conductors from the environment. However, it is important to ensure that the LFMC is properly installed and sealed to maintain its liquid-tight integrity. The length of the FMC used as an expansion joint is also an important factor. The length of the conduit must be sufficient to accommodate the anticipated movement without exceeding its bending radius. The bending radius of FMC is typically specified by the manufacturer and should not be exceeded to avoid damaging the conduit or conductors. The use of expansion fittings in conjunction with FMC can also be beneficial. Expansion fittings are designed to accommodate movement in conduit runs and can help to reduce stress on the conduit and connectors. These fittings are available in various types and sizes and should be selected based on the specific application requirements. It is also important to consider the temperature range of the FMC. The NEC specifies the maximum operating temperature of conductors, and the conduit must be able to withstand these temperatures without degrading. If the FMC is exposed to extreme temperatures, it may be necessary to use a special type of conduit that is designed for high-temperature applications. The ampacity of the conductors installed in the FMC must also be considered. The NEC specifies the ampacity of conductors based on their size and insulation type. When conductors are installed in conduit, their ampacity may need to be derated to account for the heat generated by the conductors. The amount of derating required depends on the number of conductors in the conduit and the ambient temperature. It's important to ensure that the conductors are properly sized to carry the intended load, taking into account any necessary derating factors. Furthermore, the proper selection and installation of connectors are crucial for a safe and reliable expansion joint installation. The connectors must be listed for use with FMC and be properly sized for the conduit. The connectors must also be installed in accordance with the manufacturer's instructions to ensure a secure and watertight connection. When installing FMC as an expansion joint, it is important to avoid sharp bends or kinks in the conduit. Sharp bends can restrict the flow of conductors and can also damage the conduit. If bends are necessary, they should be made with a bending tool that is designed for FMC. Kinks in the conduit can also weaken the conduit and make it more susceptible to damage. Finally, it is essential to inspect the FMC expansion joint regularly to ensure that it is functioning properly. The inspection should include checking for any signs of damage, such as cracks, dents, or corrosion. The connectors should also be inspected to ensure that they are tight and secure. If any problems are found, they should be corrected immediately to prevent further damage or safety hazards. In conclusion, using flexible metal conduit as an expansion joint can be a viable solution for accommodating movement in electrical installations. However, it is crucial to carefully consider all of the relevant factors, including the NEC requirements, the type of FMC, the length of the conduit, the temperature range, the ampacity of the conductors, and the selection and installation of connectors. By following these guidelines, you can ensure safe, compliant, and reliable expansion joint installation. To further clarify the application of flexible metal conduit as an expansion joint, let's consider specific examples and scenarios. Imagine a scenario where a long run of rigid metal conduit is installed across a bridge. Bridges are subject to significant thermal expansion and contraction due to temperature changes. Without an expansion joint, the rigid conduit could be subjected to excessive stress, leading to damage or failure. In this case, a section of flexible metal conduit can be installed in the middle of the rigid conduit run to accommodate the movement. The FMC allows the rigid conduit to expand and contract without putting stress on the connections. Consider another scenario where electrical conduit is installed in a building with known settling issues. As the building settles, the conduit may be subjected to differential movement, which can also cause stress and damage. Again, a section of FMC can be used as an expansion joint to accommodate this movement. The FMC allows the conduit to flex and move with the building without putting stress on the connections. In industrial settings, machinery often vibrates or moves during operation. The electrical conduit connected to this machinery may be subjected to vibration and movement, which can lead to fatigue and failure. Flexible metal conduit can be used to isolate the conduit from the vibration and movement, preventing damage and ensuring a reliable electrical connection. In each of these scenarios, the key is to select the appropriate type of FMC and to install it properly. The length of the FMC should be sufficient to accommodate the anticipated movement, and the connectors should be properly tightened and secured. It is also important to protect the FMC from physical damage, especially in harsh environments. In some cases, it may be necessary to use a flexible metal conduit with a liquid-tight jacket to protect the conductors from moisture or other contaminants. As mentioned earlier, the NEC provides specific requirements for the installation of electrical conduit, including flexible metal conduit. These requirements are designed to ensure a safe and reliable electrical installation. It is important to consult the NEC and any applicable local codes before installing FMC as an expansion joint. The NEC also addresses the grounding of electrical systems. Proper grounding is essential for preventing electrical shock and for ensuring that electrical equipment operates properly. When FMC is used as an expansion joint, it is important to ensure that the grounding path is maintained across the joint. This can be accomplished by using grounding bushings or other approved grounding methods. Grounding bushings are installed at the ends of the FMC and are connected to a grounding conductor. This provides a continuous grounding path across the expansion joint. In addition to the NEC requirements, there are also industry standards that provide guidance in the installation of flexible metal conduit. These standards are developed by organizations such as the National Electrical Manufacturers Association, NEMA, and the Underwriters Laboratories, AL. These standards provide detailed information on the design, testing, and installation of FMC. By following these standards, you can ensure that your FMC installation is safe, reliable, and code compliant. When selecting flexible metal conduit for an expansion joint application, it is important to consider the following factors. Firstly, the type of environment in which the conduit will be installed. If the conduit will be exposed to moisture, chemicals, or other corrosive substances, it is important to select a conduit that is resistant to these substances. Secondly, the amount of movement that the conduit will need to accommodate. The length of the conduit should be sufficient to allow for the anticipated movement without exceeding the conduit's bending radius. Thirdly, the size and type of conductors that will be installed in the conduit. The conduit must be sized to accommodate the conductors, and the conduit material must be compatible with the conductor insulation. Fourthly, the applicable codes and standards. The installation must comply with all applicable codes and standards, including the NEC and any local codes. By considering these factors, you can select the appropriate flexible metal conduit for your expansion joint application and ensure a safe, reliable, and code-compliant installation. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or inspector before installing electrical conduit or equipment. They can assess the specific requirements of your application and provide recommendations that are tailored to your needs. Flexible metal conduit serves as a practical solution for expansion joints, especially when coupled with careful planning and adherence to established codes and standards. Let's further examine specific situations where flexible metal conduit excels as an expansion joint, while also noting instances where alternative solutions might be more appropriate. Consider a scenario involving HVAC systems. Heating, ventilation, and air conditioning systems often require ductwork and piping to traverse across different sections of a building. These sections may experience varying degrees of movement due to thermal changes, building settlement, or seismic activity. When rigid conduit is used to supply power to equipment within the HVAC system, flexible metal conduit can act as an expansion joint. The FMC is strategically placed to absorb any displacement between the rigid conduit and the HVAC equipment, preventing strain on the connections and ensuring uninterrupted power supply. In another case, think about electrical panels within a data center. Data centers are highly sensitive environments where maintaining consistent power is crucial. Electrical panels in data centers are often connected to multiple circuits and equipment. Given the density of wiring and the critical nature of the equipment, even minor movements can cause disruption. Employing flexible metal conduit as an expansion joint between the rigid conduit and the electrical panels mitigates the risk of these disruptions. The flexibility of the FMC accommodates any movement, thereby safeguarding the integrity of the electrical connections. Now, let's discuss situations where alternative expansion joint solutions may be more suitable. For instance, in extremely corrosive environments, standard flexible metal conduit might degrade rapidly. In such cases, specialized conduits made of corrosion-resistant materials, such as stainless steel or PVC-coated conduits, should be considered. These materials offer superior protection against corrosion, ensuring long-lasting performance. In applications involving very large movements, the flexibility of standard FMC may not be sufficient. For these scenarios, expansion couplings or bellows-type expansion joints are more appropriate. These components are specifically designed to accommodate large amounts of movement without putting undue stress on the connected conduits. Furthermore, in hazardous locations where flammable gases or vapors are present, explosion-proof flexible metal conduit must be used. This type of conduit is designed to contain any explosions that may occur within the conduit, preventing them from spreading to the surrounding environment. The NEC provides detailed requirements for electrical installations in hazardous locations, and it is essential to comply with these requirements to ensure safety. In addition to these specific situations, it is also important to consider the overall cost-effectiveness of using flexible metal conduit as an expansion joint. While FMC is generally less expensive than other types of expansion joints, the cost of installation and maintenance should also be factored in. In some cases, it may be more cost-effective to use a more expensive type of expansion joint that requires less maintenance and has a longer lifespan. When installing flexible metal conduit as an expansion joint, it is essential to follow the manufacturer's instructions carefully. The instructions will provide specific guidance on the proper installation techniques, including the correct bending radius, the proper spacing between supports, and the proper tightening torque for the connectors. Following the manufacturer's instructions will help to ensure a safe, reliable, and code-compliant installation. Regular inspection and maintenance are also essential for ensuring the long-term performance of flexible metal conduit expansion joints. The conduit should be inspected periodically for any signs of damage, such as cracks, dents, or corrosion. The connectors should also be inspected to ensure that they are tight and secure. If any problems are found, they should be corrected immediately to prevent further damage or safety hazards. By following these guidelines, you can ensure that your flexible metal conduit expansion joints provide reliable performance for many years to come. And remember, always consult with a qualified electrical engineer or inspector before installing electrical conduit or equipment. They can assess the specific requirements of your application and provide recommendations that are tailored to your needs. In summary, flexible metal conduit can be an effective solution for expansion joints in a variety of applications. However, it is important to consider the specific requirements of the application and to select the appropriate type of conduit and installation techniques. By following the guidelines outlined here, you can ensure a safe, reliable, and code-compliant installation.